today I'm going to do science fiction. This is what I believe will be the finance to come. Let me give you or remind you, in case you don't know, how mathematical finance happened. There was really no mathematical finance to speak about in the year 1900. It's a mistake to think that Bachelier, who wrote his thesis in 1900, who became very famous, really had anything to do with quantitative finance. It didn't. It was a very nice theoretical development, but first of all, it was financially wrong and useless because people were not ready to use it. It was just a nice development. It's really an offshoot of something else that happened around the year 1900, which is the discovery that diffusion processes have to do with differential equations. So, as much as I appreciate the work of Bachelier from 1900, it has nothing to do with mathematical finance. Nothing. The equation happens to be similar, but there's no relation. The relationship happened in the 80s. Sorry, mathematical finance was really born in the 80s. It was born in the 80s because in the 70s, and now everybody knows about this because we're talking about all the time, in the 70s we had the first Iran-US war. And that's why mathematical finance was developed. Because the war gave rise to tremendous volatility, tremendous, very, very bad markets. Every year, 6 banks went under in the United States. Every year. 2023, we had 3, and it was like a big thing. 6 banks every year would go under. It was very bad. It was very, very bad. The recession that followed, 1982, was a disaster. Inflation, recession, it was very, very bad. And to remedy that, people had to do something. Financial markets developed to provide insurance to financial participants. And the insurance was provided in the form of derivatives. Derivatives were the salvation for derivatives markets. And the derivatives that developed were not on stocks. The stock was not the issue. The issue was interest rates. Swaps. The 1980s was the decade of the swaps. And I cannot stress what a big development that was. I know that in your studies in mathematical finance, swaps are barely ever mentioned because they're mathematically very simple, right? Variable coupon bond here, fixed coupon bond there, take the difference, big deal, next chapter. Well, the thing is, that was a tremendous development because it allowed participants to lock in interest rates and not be at the mercy of financial markets. So the swaps was the big explosion, and billions of dollars of swap derivatives developed in the 80s. Okay. And that's when mathematical finance happened. Because mathematical finance was never there to develop beautiful solutions to problems. It was always there, like Bachelier was doing. Mathematical finance was there to solve real problems. And that is why it became successful, because it solved real problems, and mathematical finance made money. A lot of money. Great. And then, other derivatives developed, and it was really all great. And then risk management and that. Now, we are now undergoing some very interesting revolution, which I will explain today. And finance is going to be the one that's going to finance it. See, the thing is, nothing happens without money. Nothing. Well, if you become philosophical, maybe you find a few things that happen without money. But development is financed. And what I'm going to talk about today is a new type of economy that is developing, that is going to require, of course, money, financing, but also new considerations of finance that we can use the finance to build upon. So I want to talk a little bit about business first. And I want to give you a comparison just so you understand what we're talking about. I have here the GDP of 4 countries. These are the largest GDPs. It's debatable whether India or Japan is bigger, depends how you count, but they're very similar. So I have India about $4 trillion, I have Germany about $5 trillion, I have China about $20 trillion, and I have the United States about $30 trillion. You're familiar with these numbers, and these are big numbers. These are about the biggest numbers we have on Earth, right? Well, no, that's what I want to show you. Let me, everybody's talking about the price of gold. Are you following the price of gold these days? Yes? It's like through the roof. It's as big as it ever has been, all-time highs, right? Okay, what's the price of all the gold in the world? Both the one that has been mined and the one that still is inside the earth. Inside the earth, I mean mineable. There's little molecules of gold in the earth that we have no hope of ever getting to. So I'm not including those here, but including all the gold that exists inside the gold mines that we could mine if we wanted to, and all the gold that has already been mined by humanity over time. It's about that. It's about the GDP of the United States. Okay, let me talk about the amount of oil that exists in the world. Oil is the commodity of the 20th century. Every period in human history has a commodity attached to that. A commodity is like bronze, right? Rocks, fire, oil. Oil is the commodity of the 20th century, and it has dictated everything that happened in humanity in the 20th century. From wars to industrial development to the creation of AI. Oil has fueled all of that. The amount of oil that exists on Earth is about $200 trillion. There's several orders of magnitude the GDP of the United States. In fact, it's probably like the GDP of the rest of the world, just oil. Okay, so oil is, you can see why it's such a big deal. Right? Now, that's the 20th century. Let me take a peek into the 21st century and see if there is a number which is bigger than that. Anybody has any idea of what could be bigger than that?
Cobalt.
Cobalt? Okay. How much cobalt is in the world?
Not so much.
Not so much.
It's very expensive.
Yeah, exactly. So I haven't done cobalt, by the way, but I have something bigger than cobalt. But that's very good. But I will add it to my next time I teach this course. Okay. Anybody else has any other guess? What would be bigger than that? I need you to think science fiction. I need you to think for the future, not about what we're dealing with today. Say something.
Can I say another one? Data. It's not that difficult.
Yeah, that's the thing. Data is very hard to value. I mean, you can now get, well, love. Love is extremely valuable, right? Or, yes, right, we cannot live without love. I don't know how to attach a price to that, but...
Water?
Very good. Water. But what's the value of water?
Depends on how much.
The thing is, if... so, water... That's very, very good, by the way. You're 2 steps ahead of me now. I'm coming to... What's the value of water? Do you know the value of water? What's the value of all the water in the world? Some people will say it's for free. Right? What are you talking about? Just go, there's a lot of water, just walk down the hill and you get as much water as you need. Right? And it's considered to be for free. However, if you're going to buy it, if you buy a little bottle of water, it's $2 million a ton. Okay? It's much more expensive than oil. So we don't know the price of water. And I'm coming to that. Water is a fantastic example. I'm coming to water. So the thing is that with water, the thing is that we don't have the price, but I'm coming to that. Electricity. Okay, so there we know the price of electricity. So let me calculate the price of electricity. We know the price of electricity. I don't know if you pay electricity bills, but let's say that the price of electricity is about 10 cents a kilowatt hour. Yes? That's about right. I mean, in Italy, it's like, well, like a euro a kilowatt hour, depends on where you go. But it's, let's say it's 10 cents a kilowatt hour around the world. So let me do a calculation. At 10 cents a kilowatt hour, what is the value of the photovoltaic energy I get from the sun? Is $400 trillion per day. Per day. So unlike water, which is there, whatever I don't know the value of water, I'm coming to that. But this is generated, this is wealth generated at the rate of $400 trillion per day. This is going to change everything. If we can get it, of course, that would mean we'll have to figure out a way to capture all of the photovoltaic energy we get from the sun. So forget about growing vegetables, right? Because we take all of it. It's an exaggeration. It's just to give you an order of magnitude. But this, yes.
Is this only from the sun directly, or also includes, like, for example, aeolic?
Okay, no. So I'm coming to that. I'm coming to that. Okay, now, this is very good. I got you thinking in the right. It's good. I got you into the right mindset. Okay. Wind comes from the sun, right? Because wind comes from difference of temperatures, and that comes from the Earth's activity to turn the sun energy, not turning into electricity, but turning into wind. You could do that too, right? The Earth doesn't care. The Earth does whatever the Earth does, and I'm talking about the Earth in a minute, right? So of course, if I absorb all of that energy coming from the sun, then I have no wind. I have no vegetables. I have no. It's a theoretical number. But it's a theoretical number to give you an idea of what we're talking about. Let's be very ambitious. Let's say that I can capture 0.01% of that. I leave you the other 99.99% for you, for your wind and your food and everything. I become wealthier than the entire United States. Right? Well, these things are beginning to happen. We're on the cusp of that. We have the technology for that now. We didn't up until a few years ago, but now we do. The photoelectric effect is about 100 years old, but it was not industrially developable. But now it is. And which is the country that's doing that? Which is the country that believes in that number?
China?
China is the only one that believes in that number. Actually, it's not the only one. There's a second one, Spain, for example, at a much smaller magnitude, right? But if you can capture that, it's fantastic, right? See, oil is nothing. This is all the oil that was and will ever be. And by the way, oil, unlike gold, that always stays there, or water, which always stays there, that goes away. Okay? So, by the way, a corollary of this is that it's kind of silly we pay for energy. Energy, there's so much of it that it should be free and unlimited. So we live in a world where energy is a constraint, when in fact we have much more than we will ever need, if we find a way to get it. So whichever company comes up with a way to make this industrially doable, and we're very close to that, that will be I'm going to say the biggest company, no, because there are going to be even bigger ones that I'll tell you later, right? But that would be a fantastic company, right? Now, so you know I'm not crazy telling you these things. I started my investment company in 1999. And I was a professor, and I started to talk to investors, and I got to see how people thought about the developments of the time. 1999, what people were talking about in the investment world? What do you think? What was the thing in 1999? Technology companies. Every investor was making fun of these stupid companies called Google and Microsoft and this and that. And I was listening to that. I said, well, okay, here I am. I'm a mathematician. I have to learn from these people, right? And everybody was talking about how a company like Google will never amount to anything. It was perhaps entertaining, and that's it. And look at the result. The 7 largest companies in the world today are the companies that people were making fun of in 1999. Just because no one understood what was really happening. Now, I don't have a crystal ball. I don't have a way to tell you what's going to happen. But I'm going to give you enough elements so that whatever happens, you're ready for it. And suddenly that number is staggering. Okay? But it's not the only one. Let me do a little bit more. Okay, let me continue talking about it. Do you understand where I'm going with this? Okay, so let me just open up a little bit, and let me now consider something very strange, which I want to consider the Earth as an asset management system. We've learned about investing. Investing is managing your assets. That's what investing is, manage your assets. Well, the Earth does it all the time. So let's get a little bit into how the Earth does it. The Earth has been doing that for a long time without the participation of humans. You know, we've been guests at participating in that. So let me reflect on how the Earth works as an asset management system. The Earth has a source of energy, which is the sun. And that energy is what causes everything to happen. So for example, heat. That energy we get from the sun gets translated into heat. And that's why we are warm. It's translated into rain because heat, we have water on Earth. We're lucky we have water. And that water with heat evaporates and that it creates rain. So it creates a cycle. And the Earth is taking care of that. The Earth creates rain. Now, that rain, because we have living organisms, creates biomass. And before it becomes biomass, it becomes food, and we eat it. And we eat other living beings that eat that food too. And we have a cycle of life by all of us eating each other. Right? All right. Now, let me group this into the alphas and the betas. I told you everything's alpha and beta, right? So let's see how we as humans manage these assets, because we're intervening into the way the Earth has been managing this for a long time. And we have a way of turning heat, which creates wind, into electricity. We've created that. That wasn't there before the humans arrived. The humans have been doing that. We've also taken the photovoltaic and electricity and photovoltaic energy and turned it into electricity. We've done that. It wasn't there before the humans arrived. Okay? And we've taken the biomass and we turn it into oil. And we've taken the rain and we've taken into potential energy that can also be turned into electricity. So we've done that. Sorry, that's the comment for the oil. I was looking at the wrong slide. All right? We have done that. The Earth had its own management system and we've developed our own on top of that. Now, of that, some of it is active management. It was the alpha, remember? we've talked about a lot of alpha creation, right? That's what it is. This is alpha creation. And then we have the beta creation, which is just pumping oil from the central bank reserves. It's been saved by the earth for a long time. We just take it. And the 20th century has been the century where we've put all of our focus onto that. The central bank has a lot of money. Why would I create new wealth? I don't care. I just get that money from the central bank. You have inherited a big fortune from your parents, just use it. Why do you have to create a new one? Right? That's what that is. That has been the economic cycle of the 20th century. And it's been wonderful. We've managed to do a lot of things because there was so much stored energy that we could use for a lot of things. Turning the lights on, powering computers, powering the camera that's recording me right now, and all of that. It's been great. But that doesn't generate anything. The energy that has been generated has been managed entirely by the earth without us participating until recently. And that has been used to, well, create wind, rain, living beings, and eventually biomass, which then goes back into the central bank to use in future generations if they continue to want to use oil. Okay, understand? So that's the perspective. And this is changing now, as you know. It's changing. There's some economies that continue to be focused on that, and you know which one I'm talking about. And others say, well, you know what? There's lots of other things out there. Why don't we try to get it, which is, you know, perhaps cleaner, perhaps easier, perhaps cheaper. And certainly it is going to be a lot cheaper. Okay, so that's one thing. But now I want to talk about water. I wish I could say more things about water, because water is perhaps the most interesting, but it's the least understood. And to show you how little understood it is, I have here a paper to share with you. You may have heard about this. This is a paper that talks about the water consumption of large language models. You know, this is a big deal, right? Okay, so there's a number here which is mentioned. I'll mention this number to you. The amount of water that was used to train GPT-3 was 700,000 liters of water. Okay? 700,000 liters of water. And there's a big concern that that's a lot of water. And GPT-4 is more, and GPT-11 will be a huge amount. And that's a big concern. Okay. Let's pause and reflect on that a little bit. I told you that the reason we had such a successful financial system in the 20th century is that accounting, trustworthy accounting, was introduced in 1934. You may have forgotten, but I did say that. Because with trustworthy accounting, I can believe the numbers that are given to me. That was not true in the 1700s. In the 1700s, if I wanted to buy a company, I had to hire my own group of investigators to tell me if these numbers were right. But now, no, the numbers are right. If they're wrong, someone goes to jail. So the numbers are right. So the problem we have now is that everything that I'm telling you, we have no accounting for it. And to show you that we have no accounting for it, I just need the abstract of this paper to show you how little we understand about that. I'm going to take all the numbers which appear in that abstract. So there's some numbers there, right? 700,000, 4 billion cubic meters. I don't know if you can read that. There's numbers there. You don't have to read them. But I'm going to write these numbers in my units. I want to do accounting for a minute, water accounting. And I want to rewrite those numbers using one unit that I'm going to make up today. And that's a unit which is the following. And let's see if you understand the unit that I'm going to use. Anybody's a vegetarian here? You're a vegetarian? Great. So let's say you're a vegetarian. Say, I'm not a vegetarian. Okay? All right. So you consume food, and I consume food. And we consume more or less the same amount of food. But you do not eat meat and I eat meat, right? So how much more water is needed for my food than for yours? You understand what I'm saying? So the water consumption of a meat-eating person compared to a non-meat-eating person, that difference is how much? Do you know?
50,
Sorry?
50,
50 what?
50 times.
No. I don't know. I need units. I'm going to do accounting. Accounting means I need units. Okay? They're not going to be dollars, they're going to be liters of water. So how many liters of water do I consume in excess of you?
Like per year? Or...
Per year, yes, per year.
1,000 liters.
How much?
1,000 liters.
100,000 liters. So my water consumption, because I eat meat, is 100,000 liters more than you. By the way, I'm not saying, don't misunderstand anything I will tell you today. I'm not making any moral statements or ethical, okay? I'm not saying that I'm doing anything wrong or you're doing anything wrong. But if I did my accounting of the water, no one does accounting of water consumption. No one does, right? People do accounting of how much you spend for a pizza or a coffee. We know that's $2, that's $15 or Swiss francs. But our water consumption, we don't. Our air consumption, we don't. But I want to start with water. Water is very interesting, right? So my water consumption is 100,000 liters per year more than you, just because you chose not to eat meat. Understand? Okay, so let me rewrite these numbers and with my units. So training GPT-3 is 7 people. So the training of GPT-3 will be offset if 7 people said, oh, I become vegetarian now. That will offset that. You see? Let me, I'm assuming it was 50 of us, it was close to 50, so all of us, okay, I'm assuming there's 50 meat eaters here, okay, so you're not in that group, okay, I don't know who else will. So with 50 meat eaters, we already exceed GPT-3. And by the way, this was for training, that's a once in a lifetime use. We do that every year. It's not that consuming water is bad, okay? I'm not saying that. Don't misunderstand me. But that's what this paper is talking about. It's talking about consumption of water, right? So I'm going to use the same metric, consumption of water. All of the AI globally, all of the water consumption of all AI systems globally, data centers and everything, is estimated to be between 4 to 6 billion something. Well, that's 50,000 people. That's a district in Zurich. That's it. The UK, 100,000. And all the meat which is consumed in the world is 7 billion. No, 7 billion people. Sorry, I have the, 7 billion people, of course. So this is just to give you that's all the water consumption of the UK, okay? And that's how much water we consume in the rest of the world. Understand? So this is, where did I get these numbers from? Of course, these numbers are estimated because we're still not good at water accounting. We're not good at accounting of almost anything except financial companies. That's where mathematical finance exists, by the way. Imagine doing mathematical finance without accounting and numbers that we can't trust. But if I could do, these are fairly sound numbers that I have here. Fairly sound numbers. Okay.
Sorry, why is the UK so small?
It's
like only direct water that we drink.
It's the use of water in the UK. Yes. So let me pose a question, which is, what's the value of water? See, Ines, you had a very good answer, but I don't even know what the value of water is. With electricity, I do, right? And the amount of water, as you know, is more or less constant. It stays there. It doesn't really go anywhere. Oil disappears. Water is the same. and the energy from the sun keeps on increasing every day. Okay, so what I want to say is that this is bound to mean something. I'm not going to tell you what yet. Okay, I will bring out a crystal ball at some point, but for now, I just want to make a reflection on this. Why? Because these are technologies that are about to happen. And I can already see certain, well, China in particular is making a very big effort to change the equation into something different. So so let me leave that open. And now what I want to do, I want to say, well, what does this have to do with finance? I want to go and ask the question about what this has to do with finance, okay? Do you need a break? No? Can I continue a little bit? Okay. Let me find the optimal break point, okay? I do have an optimal break point. So what I'm going to do now is I'm going to go to the year 1990, precisely to May 24, 1990. And I need you to understand the history. History is very important. You need to understand history. So every time I lecture, I like to give the historical context for things. So let me give you the historical context for this news item in the New York Times on May 24th, 1990. It was a shocking a piece of news in the New York Times. It talks about a decision by Harvard Investment Management and the City University of New York to divest from tobacco stocks. Okay, let me explain this. I need you to understand the significance of this news article. Harvard University is the university with the largest endowment on earth. Today they have like $35 billion in the endowment. What is the endowment? Universities outside of Europe, they have their own pool of money. They work as autonomous universities. They get some money from the government, but many of them are private. And the University of Toronto, for example, is public. We get money from the government, but we still have an endowment. Not like Harvard, but a few $1 billion. What is that? The universities act as financial entities. They need money to operate, and they do not assume that all that money will come from the government, like it happens in Europe. Okay? So they have their own operating budget, and they try to get money from public sources, but also private ones. And we have an army of people whose job is to knock on people's doors and get me money. And that money goes into an endowment fund. Harvard is $35 billion. Back in 1990, I don't know what it was, probably 10 billion, I don't know, doesn't matter. But it's the biggest. And like any other endowment, like any other insurance company, the money that is collected, it does not just sit on a bank account. That's silly. It's a lot of money. It's invested, and it's invested taking into account the needs of the university in the future. Some of this money is used to pay professors. Some of this is used to give grants to students. Some of it is used to pay other things. So it's invested. And it's a fairly large investment fund. Today is $35 billion. $35 billion is pretty big. I did not include the small numbers in my original description, but just to give you an idea, the 35 billion is probably bigger than most Swiss private banks, just to give you an idea. Okay, so Harvard University is bigger from a financial perspective than many Swiss private banks. A lot of money. And they invest. And not only they invest, they are very good investors. Very good investors. Harvard Management, Yale Investment Management, University of Toronto Investment Management, very good. These are very good investment organizations. And sometimes they're very innovative. And part of the reason is that they don't have to, I mean, they run very well. They run very, very well. And Canada is very good, actually, as a country, to have this type of investment funds. Better than the US in general, although Harvard is in the US. So in 1990, actually in the 80s, the industry of choice was not the tech industry, it didn't exist. It was not the energy industry. It was the tobacco industry. In the 80s, the industry of choice was the tobacco industry. The tobacco industry was fantastic. From a value investing perspective, it's the best. They produce this thing called cigarettes. They cost a penny to produce and they sold for $1. That was the sentence, you know, make them for a penny, sell them for $1. So from an investment perspective, it's the best thing you can have, right? We saw fundamental investing a few days ago, or yesterday, I forgot when, we saw, right? So from a financial perspective, it's the best. And hedge funds were fighting to own them, and food companies were fighting to own them. Nestle was fighting to own tobacco company. It was fantastic. They were money makers. But Harvard said, sorry, no. I don't want to invest in a company that kills its customers. And they alluded to ethical reasons for that. I will a little later discuss financial reasons for that. But that was a shock. It's what today would have been called perhaps the first example of wokeism. Do you know wokeism? Woke, yes, you know about that? Yes. So I'm sure that some, we didn't have that term. No, the term is very old. It's certainly much older than that. It's a term that was developed in Africa many, many decades ago. But this would have been considered to be a woke move. But totally unexpected. Every investor was talking about this. Why did they do that? Why did they decide to divest from the most profitable companies that exist on planet Earth? And they said, well, I don't want to invest in a company that kills its clients. So, okay, how weird. What do I care if I kill my clients? It's great money, no? So I'll say more about that. It's coming, okay? You see where I'm going with this? Maybe, I don't know. So let me do a very simple analysis of Harvard investment management decisions by looking at, I'm going to do something. Don't misunderstand what I'm doing. I know this is very silly, but I do have something to say. I'm going to look at the evolution of the S&P 500 since 1990 and the evolution of, it's hard to find a tobacco company that was continuously trading all that time. So I took British tobacco company, it's always there. And I'm going to compare them, okay? It's not as silly as it looks, okay? It's not as silly as it looks. When I compare them, I see that, well, it seems that they were right at the beginning, right? For a few years, the S&P 500, which is in yellow, was outperforming the tobacco company. You see that on the graph. But of course, that's a very silly thing to say. First of all, an endowment has a very long time frame. 30 years is not a long period of time for an endowment fund. They need to guarantee the existence of Harvard University for the next hundreds of years. So 30 years is not very long. Okay, and certainly what happens in the next 5 years, they don't care. It's interesting, but they don't care. They don't drive their decisions because of what will happen in the next 5 years. They don't. In fact, you can see that around the year 2005 or so, they started to do better than the S&P. So damn, that was the wrong decision. And we're going to ignore all the morality here. No ethics, just hardcore finance, investing. That's all. But then look what happened around the year 2018. Sudden drop in value of the tobacco company. In the S&P, you can see the financial crisis of 2008, you can see everything there. You can see even COVID-19, you can see everything. And then suddenly, that tobacco company drops in value. Why? You know why? A few things developed. Regulation, competitive product, vaping came up, lawsuits, but there was something else. That was the beginning of the democratization or the spread to retail of something that had already been there for a while. And that is something that we will call today ESG. ESG is 3 letters, stands for environment, social governance. I want to talk about that today, okay? Don't misunderstand me. I can be misunderstood many times during my lecture today. I'm not going to say that this is the future of investing. It's actually the past. But in 2018, as I think I mentioned to you a few days ago, the mutual fund industry worldwide had tremendous difficulties to stay competitive. Markets were not performing. They were all betas. Oh my God, how do I distinguish? And then they started to come up with these new marketing ploys. So, well, I invest in responsible assets. The same thing that Harvard did in 1990. It became fashionable in 2018. And then companies like that said no one wanted them. Yes, they continued to produce products for a penny that they sell for $1, but now the risks are too high and no one wants them, and they dropped in price. So perhaps, now I'm exaggerating a little bit, perhaps you can say that Harvard did not know when that was going to happen. Said that will happen at some point. So you know what? We get out of that early. We just don't want to be part of that. That's a financial decision, but it's a financial decision. Again, the economics of those companies didn't change. And by the way, the litigations were not that damaging to the amount of money they continue to make. But a social trend was created. Many people with a lot of money decided they didn't want companies like that in their portfolio. Many teenagers with a little bit of money decided they wanted to have GameStop in their portfolio. And it created a momentum trade that lasted a week. This was a lot of people with a lot of money. They created a trend that has lasted 10 years. It may continue to stay there or not. We don't know. Understand? And this, I told you, this is a new thing that's happening in finance, and it's very clearly seen here in this particular case. Okay? Now, there's another reason why Harvard investment management decision was a sound one. And that's from a different perspective. In fact, it's consistent with my previous story. Their thinking was, okay, I can invest in my company, in my tobacco companies today, and I can make money. But I'm a long-term investor, very long-term, like 100 years into the future. And something tells me, my smart analysts tell me, that if we continue to invest in these companies that kill their customers, we may have problems in the future. So why don't we get rid of that? And it was a matter of deciding this is how risk management works. This risk is certainly not worth my money. You don't know it's going to happen for sure, but the probability that it might happen is enough for you to say, I don't want to be part of that. And this gave rise to what we call impact. It was called impact investing at the time. Now it's called something different. These things change labels every so often because you will get tired of the old labels and they need new ones. But this was something that was created, impact investing, which is to take into account the impact of your actions, your investment actions, not just the impact on profitability. What is that doing to your environment? Because that may come back and hurt you. Profitability is not the only objective function. You need to have others. And that was developed many years ago. Then it became this thing that we call ESG that has a lot of problems. In fact, still today, we don't have accepted rules that tell us what is a good ESG investing and what is not. And I'll talk some more about that. It's a very important point. Although ESG, I think, is being phased out, perhaps to be replaced by something different. But eventually, I think this is what will be what I will call today's sustainability, and that is just investing with a very wide set of objectives, which includes your financial profitability, but also other things. Okay? Like not going to jail. Or suddenly they say, I have the best product, no one wants it because they don't like that I kill my customers. Understand? Okay, so that's what I'm going to be talking about today. This thing will be called sustainability. And I like to say that sustainability is the new liability. Liability is something that if you don't take care of that, that will take care of you, right? And that's not so good. So that is the context in which I want to discuss with you today what is happening in the world of investing and how AI will unlock tremendous. Without AI, nothing that I'll tell you today will happen. Nothing. We need AI for that. And with AI, a lot of what I tell you that could happen, I think will happen. And I want you to be aware of that. Now we can take a break. We come back in 15 minutes and I'll get to the bottom of what this means today. Okay? 15 minutes. Let me get a little bit deeper into what I believe is going to be driving development and financing for development in the next few years, maybe few decades. I want to bring to your attention the Sustainable Development Goals of the United Nations. You may already know them. It was a remarkable accomplishment of the United Nations. 193 countries agreed that what is written on this slide is important to everybody. So 7 billion people have agreed, through their governments, have agreed that this matters. So some of the things that you know, no poverty. They say concerted effort that poverty is a bad thing. We want to get rid of it. Zero hunger, good health and well-being, quality education, gender equality, clean water and sanitation, affordable and clean energy, and so on and so forth. So I'm not going to talk about all of them today, but I'm going to talk about the financial implications. This is a course on finance. It's not a course on public policy. It's not a course on environmental science. It's a course on finance, investing, and using AI. And I want to focus on some of these things for you to see the financial needs that will arise as these things are being obtained. For example, I mentioned energy. When it comes to energy, we say affordable and clean energy. That's one of the goals. So what about if I say that I have a way to create free unlimited energy, which, by the way, is clean, generates I just take things that come to me from the sun. That will certainly achieve that. So there's 7 billion people who said this is a big deal. And other things. I'm not going to talk a lot about energy anymore in this course because, a number of reasons. I will talk about some things related to that. All of these are related, and that's what the 17th goal is, partnership for the goals. They're all related somehow, and this is what I want to address to you. Now, the arrival of ESG that I mentioned to you around the year 2018, and by arrival I mean to the mainstream. ESG has been there for a long time, but the arrival of ESG to mainstream in investors in 2018 is through the consideration that some of these goals have implications which have to do with the environment, which gives rise to the E pillar. Others have things to do with social elements, which gives rise to the S pillar, and others that have to do with the G pillar, things that have to do with good governance and fairness. And I have here a video. I don't know if I want to play this video for you or it's not, but this is a video of what's happening in Harvard today. So I talk about Harvard in 1990, and this is a video that talks about what's happening in Harvard today. I
This is democracynow.org, the War and Peace
It's
Report.
not
I mean,
important
living with
what
Mary
it's being
Chase.
said.
We try not to
Even
have
people in
refusals
Zoom,
of
I don't know if you
continuing
can hear
blockade.
this.
The
It's enough you hear
administration
me.
says, while calling on the school to divest from fossil fuels.
Divest from
However,
fossil
that's the
fuels. That's, for me, that's the key. This is what people are talking about in Harvard. Not talking about divesting from tobacco companies. They're talking about divesting from fossil fuels. Now, like I said, this is not a course on public policy. It's not a course on environmental science. It's a course on investing. So I want to address these things from an investing perspective. And for that, I need to explain first a little bit what this focus on fossil fuels is. I know that you probably know, but I still need to tell you somehow my perspective on that so that we can go into the investment elements of this. And I need to remind you what a greenhouse emissions are. I should start by saying that I personally disagree with the term greenhouse emissions. I think it would have been better to call it the microwave emissions, because the phenomenon that happens is closer, in my opinion, to what happens inside a microwave oven than what happens on a greenhouse. I think the greenhouse is misleading. And I suspect you know this, but I don't know. There is gases that we have in the atmosphere, which we've learned through lab experiments and spectrography measurements, that they interact with radiation in a certain way. Radiation makes molecules move, spin. So the CO2 molecule, CO2 is my first gas, the CO2 molecule contains a carbon atom and 2 oxygen atoms, and it's shaped like that. And when certain radiation hits it, it spins. And you know through thermodynamics that when molecule spins, it becomes hot. That's what temperature is. It's kinetic energy at the molecular level, right? It's actually not the sun rays that make, the sun rays go through this, is no problem, but the sun rays, when they get reflected from the earth and they hit the molecule spins. It's exactly what happens to water inside the microwave oven. You've all used the microwave oven, right? And you know what happens? You put the plate, if the plate has no lead, if you put a plate and there's some food in the plate and the food contains water, the plate does not contain water, the food contains water, and you turn on the microwave, then radiation is sent inside the oven. The radiation will interact with whatever is there, but the radiation has been engineered so that it interacts with water molecules. And the plate has no water, so the radiation just goes through it, nothing. And that's why the plate is cold and the food is hot. That's how microwaves work, and you know that. In fact, everybody knows that. And that's why you don't put a metal fork inside the microwave, because it's going to start doing crazy things, right? In fact, you'll probably burn your house if you do that. We've learned these things. This is the same. It's exactly the same phenomenon. The rays that get reflected from, scattered is the right word, scattered from the earth. They hit these molecules and makes them spin. And CO2 is one of them. Now, CO2 is produced in 2 ways. One is in a natural way. CO2 is actually the molecule of life. If it wasn't for CO2, there'll be no life on planet Earth. Okay. I say here it's produced by decomposition, ocean release. Let me talk about that. This is very interesting. It is true, but the reason is that CO2 dissolves in water. CO2 dissolves in water, and it dissolves in water to a certain amount, which is proportional to the temperature. Has it ever happened to you that you take a bottle of water from the fridge, you let it sit there, and then it develops bubbles inside? Have you seen that? Do that. Do it. Take a bottle of water, bring it outside, and as it becomes room temperature, you see these bubbles inside. What's that? CO2. It's the CO2 that is being released by the water because at warmer temperatures, you release CO2. Lab experiments. You can do this lab experiment at home. You know what I'm talking about. Yes, you take a bottle of water. If it's been in the fridge, cold means it dissolves more CO2. Warm dissolves less CO2. And what is it going to do? It stays there in form of bubbles, right? So the ocean is a huge water bottle. With cold temperatures, it absorbs CO2, and with warm temperatures, it releases CO2. So it's a big sink of CO2 and a big emitter of CO2, the oceans, right? But many, many other things. Now, that's natural. It's been happening for a long time. And you may have heard that we're very lucky in planet Earth. We have CO2 in the atmosphere because that has made the Earth warmer. Maybe 18 degrees on average warmer than it would be without CO2. It's pretty good. Canada would be a very bad, even worse place from a temperature perspective. So it's good. And we are used to this nice temperature. It is comfortable. Things don't freeze. We have liquid water, which is good for life and this and that. And we're happy with that, right? Now, what happens when you have too much CO2? Well, the radiation hits the CO2 and then things get warmed up. And we don't like it. We don't like that the Earth is suddenly warmer because it could destroy the equilibrium that exists, and we don't know how to deal with that. We depend on equilibrium. We depend that yesterday was the same as today, the same as tomorrow, right? Well, I'll say something. I'll tell you. The amount of CO2 in the atmosphere is very small. We measure it in parts per million. It has a very big effect. And traditionally, we've been able to analyze this by looking at, as you know, CO2 gets trapped in water, right? So if you go to glaciers or places where there's ice, that CO2 is trapped there. And through there, we can guess what the CO2 levels have been in the atmosphere for the last 400,000 years. We know that. We know that. So we know we've been at a very comfortable 250 parts per million for a long, long time. Although we know that at some point it was at 6,000 parts per million. That was in the time when the Earth was full of volcanic eruptions and, it was volcanoes everywhere. Of course, life had a very hard time to find its existence there. We don't like that. We don't like that. We don't want to be in that situation, right? So for a long time, as life has developed the way we know it, for the last 400,000 years, we've been at a very comfortable 250 parts per million. Now we're going up. We're about 400 parts per million, almost double. And we don't have enough knowledge as to know what effect that will have. But people are doing computer simulations. Now we have supercomputers. Supercomputers can simulate things because you can simulate all the basic phenomena that come from. You can simulate radiation. We can simulate the Navier-Stokes equation that moves the air from here to there, and then we can simulate rain. All of this is simulated in computers. And when people simulate in computers, of course, we did all sorts of different scenarios, crazy ones. And there's about 20% of those scenarios which are really, really bad. 80% we don't know are okay, but it's 20% which are really bad. We don't know for sure that things will be bad. We don't know that. No one knows that. It's a very chaotic and complex system. Anybody who has done dynamical systems here and chaotic systems know that it's very hard to predict what's going to happen. But that's where we do simulations. And in 20% of those scenarios, very bad. We don't like those odds. Okay? And these are the results of simulations. So we know that it's risky, it's a risk. We don't know for sure, it's a risk if the CO2 is at this level or even higher because of what it might do. So that's why there was a concerted effort of 193 nations to leave that and to create what I will be calling later the Intergovernmental Panel on Climate Change. Because we wanted to bring that back down to the level that we know we're going to be okay, which is 250, maybe 300. Okay? As you know, we're now in great times of difficulty when it comes to that. In particular, the United States has just left that agreement and say, I don't care about that, and other countries are following, and that's a different discussion. Let me stick to the financial aspects of that. So, and CO2 is so important that there is a concept called the global warming potential, which is the effect that this gas has on the warming of the atmosphere. So now I'm talking about the warming of the atmosphere, the microwave effect. Okay, and we use CO2 as the fundamental unit. We call it 1. CO2 has a number 1 attached to it. It has potency 1. I should say one thing. There is a gas which is not included here, which is one of the strongest greenhouse gases or microwave gases, and that's water. It's not mentioned here. It has a potency. It's hard to calculate the potency, but I think it's about 4. So it's 4 times worse than CO2. But no one talks about water. We're not worried about water in the atmosphere, despite the fact it's a very potent gas, because it rains. Meaning that the atmosphere will have the amount of water it can take, and more than that, it just gets rid of it. So the Earth has its own system of removing the excess water from the atmosphere, so we don't care. But CO2 stays there for a long time, over 100 years. And that's what we care about it. Okay? We have another one, methane. It's also produced naturally, but it's also produced by humans. When the word is anthropogenic. Okay? Humans produce it, anthropogenic. Methane occurs naturally, but also produced by humans. And the potency is 80 times that of CO2. So when the Nord Stream was blown up and I don't know how many tons, gigatons, megatons of methane were released into the atmosphere, it's as if 80 times that was released to the atmosphere in the form of CO2. It's much, much worse. Because that's a carbon molecule and 4 hydrogen molecules around it. And when they are hit by this radiation, it spins a lot faster. So physics. Okay? The good thing about methane is that it has a lifetime of 10 years. After 10 years, by itself, it oxides and it becomes CO2. So the potency drops, but it takes 10 years for that. So the Nord Stream, that was blown up less than 10 years ago. In a few years, that methane that was released from the Nord Stream would have become CO2. So the potency is less. NO2, nitrous dioxide. 1 nitrogen molecule and 2 oxygen molecules. It spins a lot faster, 300 times faster. Think of it that way, 300 times faster than CO2. It's much, much worse. And it stays there for 100 years also. It's very bad. By the way, hydrogen, oxygen, those gases, 0 impact. The radiation goes to them and they don't care. They're not greenhouse gases or microwave gases. These are the ones, okay? These are the ones which are natural. They occur naturally. In fact, we need them. For example, fertilizers is essentially nitrogen. Okay? But it's also produced by human. Actually, one of the you may have lived through this. For a long time, it was believed that diesel cars were better for the environment from a greenhouse accumulation than gasoline cars, and the reason is that the emissions are about half. Until we realized that in those emissions, which is half, which is good, there's a lot of NO2, which is much worse. And that's why if any one of you drives a diesel car, there's this additive that they discovered you cannot. The brand name around the world is AdBlue, but I think there's more. That is something which is added so that the NO2 emissions are coming down. That's an example of an investment opportunity arising from this. Okay? And a lot of these things have solutions. If you can solve any of these things, that translates into profitability. And what I'm going to argue is that a lot of the businesses of the future are going to be related to these things. This is like the .com of now. Okay? So it would be great if you can do energy for free, fantastic. But even if you can create some of these solutions which are related to these things, they're still very valuable because 7 billion people have said, I need that. Now, there's 3 more types of gases. I'll go through this quickly. These do not occur naturally. They only occur in the anthropogenic mode. They're only created by humans. So look at that. For example, the sulfur hexafluoride, 25,000 global warming potential, 25,000 times worse than CO2. And it's there for 3,000 years. It's there forever. Not so good. Now, the optimistic perspective on that is that the hydrofluorocarbons, which became very popular, not because of emissions, this is fairly recent, but because the ozone layer, that many of you have not even heard about, they were outlawed years ago. That's why we don't talk about them anymore, because they were outlawed, we don't have them anymore, and in fact the ozone layer is coming back. It's reforming itself. So these things work. Meaning that these policies which are being created and the attempt to remove these things work. And one of the topics I'm going to be sustaining today is that a lot of the financial innovations that will happen in the next few years are related, not to this is just one tiny aspect of it, but many things related to sustainability. And by the way, ESG does not play. It's an oversimplification label for what is really going on. The reality is a lot bigger, and that's what I want you to be aware of. All of the things that can be done there. So who contributes to greenhouse emissions? Well, there's the usual suspects, but also some which are not usual suspects. We know that industrial processes generate that. We know that. Any environment that consumes energy and produces heat, or even consumes heat, does that. For example, cement production. To produce cement, you have to take the limestone and heat it up to over 1,000 degrees. And you do that by burning something. It may look like you get a pack of cement, or you build a building and emissions didn't happen. Well, they happened because you needed that to create the cement. You cannot create cement without burning something. Okay? Well, no. If you can now create cement with some photovoltaic thing, oh my God, that's fantastic, right? And there are companies that are doing that. And by the way, if you create cement and you use a low emissions system, there's money for you in that, and I'm going to show you how. And many companies are doing that, and they're making money by not emitting, and I'll show you how. This is some of the new economics that are developing, right? Many universities are emissions. My university has the objective of becoming neutral in the next 2 months or something like that. Great, fantastic. But I have to say one thing. The problem with all of this is the accounting is really bad. We don't know how to account for that. We don't know how to account for water, although water we understand better than emissions, and emissions we don't really know how to account for emissions. And there are companies that's what they're doing. There are companies who sold businesses to do emission accounting. Another business that's developing. Okay, there's more. There's going to be many. We're going to find so many investment opportunities when it comes to this, because this translates into real money. Let me continue. Food and agriculture, a lot of emissions. In fact, you may have heard that one of the problems with the Strait of Hormuz is that the fertilizer that comes from there is now trapped, and we don't have fertilizer. Fertilizer is a very big emitter. very big emitter of CO2. But guess what? We need it. We're not going to get rid of that. The good thing is that we are finding ways to do carbon capture, and that's becoming very efficient. Okay, so this leads to what this whole business is of a climate change. And here's a statement about climate change from the person that used to be the UN Special Envoy for Climate Action and Finance, but now is the Prime Minister of Canada. We elected him about a year ago. Okay, and so he had a statement in favor of that. Let me just move on. And this is, I have three statements that I want to make, and I want to make commentaries. Because again, this is a course on finance, on investing. It's not a course on environmental science. And I have the statements of three prominent leaders in the world of finance that I want to comment on. The first one is Barbara Svan. Barbara Svan is a good friend of mine. She's the president and CEO of the University of Toronto, of the University Pension Plan. She was the CEO of the, this is more important than it seems. I told you about Harvard Investment Management, how they have an endowment. Okay, so the University of Toronto had a similar thing, the endowment, but we had together the endowment and the pension. Okay, and that has been now divided into the endowment here, the pension here. It still is pretty big. She's the CEO of that. And she's very outspoken that sustainable finance or sustainable investing is a big deal. And she's one of the most outspoken people in Canada. Another one is Jamie Dimon. Jamie Dimon is the president of JP Morgan. So look at what he says. He says, immediately actionable opportunities, talking about climate goals, might require more financing, not less. He said that. I want to make a comment on that, which is the reason I'm teaching this section to you today. What does that say? That's a banker. A banker saying, someone needs money, we'll be there. That's what the banks do. Banks go wherever there's money. That's their job. And if there's an arms race, they go and finance the arms race. And if there's a desire to obtain a climate goals, they show up there too. That's what he's saying. Very pragmatic. And the CEO of a Canadian bank, something similar. The economics of change and sustainability need to work. That means he's a bit skeptical, which they do when they construct it the right way, but they will be there because that's what their clients want. That's what these people are saying, and that's how banks work. So here I have an investor. Those are banks. And you can see that as an investor, financial system can and must play a critical role. And I will show you what that is, because many investment firms are very serious about this. Okay. So the story that's relevant for us started in Kyoto in 1997. This actually is perhaps the most important thing that happened for what we're talking about today, more than Paris, which I'm also talking about. Kyoto in 1997 gave the first resolution to create economic incentives for the reduction of emissions. And I'll tell you the example that was mentioned back then. There was a topic of conversation in Kyoto in 1997. They said, 1997, okay, a long time ago. I don't know if you were around, okay, long time ago. The Amazon forest is one of the biggest carbon sinks in the world. They absorb carbon. They take carbon from the atmosphere and they store it in the form of biomass. Just by itself, you don't have to do anything. Okay, great. So people say, and people were saying that Brazil should protect it. And then Brazil would say, why would I protect it for you guys for free? Why did you pay me for that? I say, how can I pay you for that? So Kyoto came up with a system which is implemented now, and it's a new market. It's a new market. Kyoto was the foundation of a new financial market created in 1987. which is to provide economic incentives for carbon capture, which I will tell you in a minute. And then came Paris, the Paris Agreement in 2015, which established the objectives that countries will have for carbon emission reduction. Okay? And it was all coordinated into my favorite article there, which is Article 2.1c in the Paris Agreement. It says that financial flows will be used to obtain decarbonization. What is that saying? That's saying that there's a new financial business. And I will show you what that business is. And I will give you the economics as to how big that business is going to become in the next 5 years. Not in the next 10 or 15, next 5. Sorry, next 4. Next 4. Okay? That's what I want to pay attention to. And this has been, again, these countries have agreed to that, despite the fact that there's a lot of noise now coming from the United States. And the important thing for you is that you need to be forward-looking. And every time there is a problem, there's financial innovation. Back to what I told you at the beginning, why is mathematical finance, quantitative finance here? Because of the problem that occurred in the 70s. That's what gave rise to the derivatives market. It was not someone writing a book, no. There was a real problem out there, and it was solved with a financial system called derivatives that required mathematical finance to understand, because it was very complicated. The situation today is we have a problem. We have 17 problems, in fact. They are very complicated. They're going to require financial solutions, which are so complicated that, as you will see, only with AI we will be able to resolve. And that's your space. And that's where I want you to be aware of what that is and what this could become. So I'm going to show you how my first example. This is Kyoto. Kyoto 1997 said there should be a carbon exchange. There should be a way to compensate, for example, countries like Brazil, for them to maintain the Amazon forest. Well, it wasn't done exactly like that. The way it was done is at the micro level. What happened is Kyoto established a way, which has been now formalized, that companies that emit CO2, governments will tell them how much they can emit for free. They emit more than that, they have to pay. Why? Because the hope is that some other companies will be doing the capture of that. So you take money from the emitters to the capturers, the companies that will do the carbon capture. And there's entire businesses around the world, people don't know about them, but there's a lot of businesses around the world whose business is to capture carbon. Many of them, today the ones that work, are nature-based carbon capture. But there's a lot of people, I know a few, there's a lot of people, scientists, trying to do physical carbon capture. But that is, they create a machine that just has air flowing through it, and they have a way to capture those CO2 molecules. And then they take all that CO2 and they put it back into a mine where it came from. That's a business. Very advanced business, technologically advanced and this and that. And I don't know that the efficiency is very big, but efficiency will eventually get better. That's happening. And I have here an example for you, a very interesting example, so you understand how far-reaching these consequences can be. Okay. I have a story. I have a few business cases for you. The first one I have is from Kenya. There was a Dutch company, Vestigard, there. And this is a company that's in the business of producing water filters. That's all they do, water filters. So they did a project for Kenya, because in Kenya, to drink water, you have to do that. And what this guy said, no, you don't need to do that. You do that. And the net is a saving of what? You don't have to burn wood now. You use the filters. So this translates into how much savings when it comes to emissions? 2.7 million tons of CO2 per year. Let's talk about this. How do I know that number?
You can do some estimation, I guess.
You can do some estimation. I mean, I can imagine this. Well, I sold so many water filters. Each filter is good for this amount of water. To boil that amount of water, I'll need this. So that's my number. Right? Okay, great. You understand? That's what we, or maybe there's other ways. They do a statistical sample. They go to a family, and in Kenyan, I don't know Kenyan, but how much wood did you? Oh, this year we burned only this instead of that. Okay, that you do. There's many ways to do that. There's not one approved way of doing that. But now this is what happens. If you can prove that your product has saved 2.7 million tons of CO2 per year, now you have a carbon capture project and you get paid. You know how much? Can you ask ChatGPT the price of the CO2 of carbon?
A new emission trading system is around
82 euros.
Euro, yeah.
Exactly, 82 euros. That's in the EU.
Yeah.
Right, what did you get? Anybody else got a different number?
Yeah, it's a bit different. In China, it's different, like 7
What-
to 15.
What did you get?
In China, it's 7 to 15 per ton, I think.
It's how much?
7 to 15 per ton.
$7.
Yes.
Yes, exactly. Yes.
And
Okay.
in US, 30 to 40.
Right. Okay. So we have the full scope. We have $7 in China and $80 in Europe. This is the range. Depends to which market you go. So you can sell these credits, and you can pick a market. You can sell them here. You can sell them there. Well, you can maybe sell them to the Kenyan government or not. And this market is still being developed. It doesn't fully exist, but it's a very big market. It's a very big market. And the prices are, as said, in Europe, their prices are very high because governments are very demanding of their companies to do carbon capture. And the carbon capture is costly, right? So you are creating a lot of demand for the carbon capture, and that's why the prices are very high. But in China, there is less demand. There is less. There's how can I say? There's less pressure on the companies to do the carbon capture, and we're going to see why. Okay, it's not for what you think. It's a different reason, and that's why the price is lower. And the fact of the matter is that China has emissions which are about half of the ones we have here. So they have less need for capture than you do here, and that's why the market is cheaper. Okay, it's one of the reasons. There are other reasons, okay? But just to give you an idea of what we're talking about, the size of this, and this is a number that I mentioned, but now it's listed here. This is a paper. If you guys care about this, I have a lot of literature. In fact, I have a whole course on this on my website with great documentation. You can go there. This paper is in that documentation. If you care, I can put it in your course documentation too. But there is about $1 trillion per year in ESG labeled bonds. $1 trillion per year. That's more than the GDP of Switzerland per year. This is very big. China is going to create in the next 5 years, is going to create a market for carbon credits, which is what we're talking about, of $4 trillion, which is the GDP of India. 1 trillion just for the airlines alone. And these markets are developing. This is the equivalent of the swap market in the 80s. You see this analogy? Do you understand the analogy? Everything that I've done today so that you can understand the analogy that I claim, and this is my crystal ball now, I claim that we are where people were in 1980 with the swaps before they started to blow up. And this is going to give rise to a lot of opportunities for you to participate in. That's the main message I want to give you today. Okay? I want to continue. I'll give you more information. I'll show you the techniques that will be needed, at least today, from where we stand today, for that, so you're ready. But great businesses, great employment opportunities for you, and all to somehow get this thing going. There's more than 20 trillion AUM in ESG labeled funds. That's more than the GDP of the United States. That's how big this economy already is. But it's going to grow. It's going to get a lot bigger. And this is the Securities and Exchange Commission just declared carbon credits to be a security last year or 2 years ago. Last year. When the Securities and Exchange Commission said that something is a security, that means people can trade it with confidence because it's regulated by the SEC. And that's how volumes are. The same thing happened with swaps. Once swap became part of the ISDA agreement, then everybody trades swaps. Snow swaps will be very hard to trade because they're not ISDA compatible. So they will be over the counter and very, very tricky. And look at the contract, where do I measure the snow? But once they become a security and, for example, they become ISDA compliant, then everybody can trade them and volumes go through the roof. And then you have a financial market that develops with its associated investment opportunities. You understand? All of this is developing now. Now, this is the price of, you gave me the price of carbon. Actually, the price of carbon is a function, it's a very complicated price because it's a function not just of where you buy them, Europe, China, California, Australia, they're all different. But also they're different depending on what industry you're in. For example, here I have the Corsia, the one in pink. That's the one that is for airlines. Airlines have to get credits from exactly that. There's different types of credits that you get depending on which industry you're in. And these markets for carbon are, as you can see, very disorganized still. They're growing. They're full of arbitrage. If you want to capture, if you want to purchase carbon, you can shop around and you get fantastic price discrepancies. You have to see if they work for you. But there's another thing, which is the brokerage business that happens here. There's two types of carbon markets. I wanna take a break soon. Okay, but there's two types of carbon markets: the regulated one, and the voluntary one. And let me explain the difference. In the regulated one, goes back to what I said earlier, which governments impose limits to your emissions, and if you're in excess of that, you have to pay. And the government will facilitate. We're going to see an example, a business case coming up, where if you have a capture project, then you get paid by the government. The government just sends money from here to there. This is the regulated market. And it's very regulated, and you have to have audit reports and disclosure statements, and which I will show you. It's fantastic. That's where all the AI is used. Without AI, you cannot do that. Okay? But it's coming. But then you have the voluntary market. We say, for example, Shell, the company Shell said, you know what, voluntarily, we're going to be buying around 100 billions of credit just because we want to tell our customers how good we are. Apple, this company does it too. You may have seen their commercial. Have you seen their commercial? If not, I'll put it here for you. Or I'll put it on the website. No, on the website I can't. It's copyrighted. But you may have seen their commercial. Tim Cook talking to Mother Nature. Have you seen that? Why maybe if I can find it quickly, I'll put it here for you. Why does Apple do that? Why does Apple want to make their products carbon neutral? I don't believe any government is telling them to do it, certainly not the American government. Why? The same thing ESG exists. They want to tell their customers that they are carbon neutral. It's a good thing to say, right? You want your customers to think highly of you. It's not only that you don't want to kill them, that was the tobacco company, but now the trend is reversed. Companies use that as part of their customer engagement program. So although they're not required, they go and they buy these credits. And if I'm Apple, I say, well, I made this carbon neutral, but this laptop, I can have no way of making it carbon neutral. Who will sell me 1 million tons of captured CO2? Who? Well, you go to a broker. And the broker says, oh, I know. And then the broker goes to some programs in Peru and this and that and says, I have it. Great. The broker has a commission today of 50%. 50. That's another business too. Carbon broker. You will never know. And I just give you an idea of the size of this market. Just in China, it's going to be $4 trillion. I don't believe that the Chinese would pay a brokerage fee of 50%. But just the brokerage business of that is probably bigger than the brokerage business of Goldman Sachs. You understand? These are the things that I need you to know, so you can capture the opportunities as they arise. If you're not aware of them, you'll never see them. But the purpose that I have in this course is for you to see those. Okay. Now, I've lost track of where I took my breaks and how long they were. And as you can see, this is something I can talk for years and not be tired. So you tell me when it's time for a break, okay? I've lost track. Is it good time now? Yeah? Okay, let's take a break. And when you come back, I think I gave you the background. Now I get into the actual technicals, okay? You cannot do any of this without AI, nothing. Okay, so everything I'm telling you here has a regulatory aspect to that. These things are not happening just by themselves. There are a number of public policy groups which are behind that. And I have some of them here. There's too many of them for me to mention. Perhaps the most important one when it comes to climate is the Intergovernmental Panel on Climate Change. And for me, the remarkable thing is this, and again, I'm being very open with you, and I hope I'm not misunderstood. As long as climate is important, I think water is actually more important. And it's being paid a lot less attention. So we are lucky that we have an Intergovernmental Panel on Climate Change, but we don't have the equivalent one in water, for example. And if that was the case, then there's other things in water that exist, but not a panel like that, which has a pretty big responsibilities to come up with directives and sometimes policies which are enforced. We also have the Financial Stability Board and others, and what they say is that we need to decrease greenhouse emissions. And that involves several things. It involves the actual processes that generate emissions, which we saw here, the energy system they rely on, but also the products and services they produce and that they consume. So, for example, one thing which is, I don't have it listed here in my course explicitly, but just to give you an idea how this is translated. You're in Europe, and in Europe, there is a regulatory regime for insurance companies called Solvency II. Solvency II regulates insurance companies. And one of the things that they regulate for insurance companies is they still use ESG as the label. They regulate their ESG activity. So if you're an insurance companies are a bit like endowments. We don't care about the liability side of the book. They pay what they have to pay, just like endowments pay what they have to pay. But they have a pool of assets that invest like endowments too, like Harvard. And that part is regulated by Solvency II. And insurance companies, they have a ESG requirement, so that if they invest in a construction project where they have to do the ESG classification of that, they need to say if it's this, if it's that. If workers go to work, the construction workers ride a bike or drive their car or take the public transportation, it actually matters to their ESG level at that level. Okay, very detailed. So a lot of these things are done from a regulatory perspective, and the financial sector is part of that. We're not there yet, but we are on its way, where if you apply for a loan, you're going to get a questionnaire about your ESG characteristics, and whether you get the loan or not will depend on that. Even if you get the loan, the rate you get will depend on that. And this is already happening with a whole branch of finance called green finance, where there are some bonds they're called green bonds, which are issued only for certain projects that have impact on emission reduction, for example. So these things are already happening. And although they look like financial products, like the rest of the financial sector, they are very different, because they have a very thin veneer of sustainability, which is the hard part. Everything else is very easy. The hard part is that veneer of sustainability. And the rule of thumb I give you for the financial sector is, when something has big volumes and is hard, spreads are big. That's where money is being made, okay? No one likes to do difficult things for free. Easy things, sure. Difficult things, no. And that's why this is big business generators. Now, I told you about Article 2 earlier. Article 2 was implemented like a decade ago. Let me tell you about Article 6, because Article 6 was implemented only 2 years ago in COP what? COP is the name of the United Nations gives to their conferences, Committee of the Congress of the Parties, COP. Okay, COP, I forgot what, COP 29. So I forgot. In Baku, I remember that was in Baku, and that's when Article 6 was created. What is Article 6? Article 6 is very interesting, because I just mentioned to you how these things work within a country. Article 6 is the inter-country market. So now you have countries trading with each other, a lot bigger volumes. So what Article 6 basically says, I'm going to go through this quickly, that countries can transfer carbon capture projects from one to the other. Of course, it makes perfect sense, because if I capture carbon here in Switzerland, that has an impact in the whole world, because we share the same CO2. It may take time to go from here to there, but it's the same one. CO2 is not trapped. It just flows freely from here to there. So this is the announcement that if carbon markets are already going to be big, now that you start to have international trades within countries, that's going to be even bigger. And this is beginning. This was somehow approved in Baku a year and a half ago. It's still being deployed. I believe it has not really started yet. When it starts, we're going to see even bigger volumes. So that's why be prepared for this tsunami of new derivatives, financial derivatives called carbon credits. They're going to be everywhere. There's different sections in Article 6. Article 2 talks about cooperation. Article 6.4 talks about mitigation. And Article 6.8 talks to a very widespread trade of carbons between different countries. So in any one of these stages, be prepared, because what I'm talking about, the size of these things is going to It's going to grow a lot bigger. I just mentioned $4 trillion in China over the next 5 years. I don't know if China is going to be able to deal with all of those things internally, but they may have to trade with other countries. Right? Singapore, for sure, is going to have to, for sure, they're going to have to buy them from somewhere else, for sure. All right, so countries are just going to be buying and selling. And I suspect a lot of the African countries are going to be happy sellers of these things if the technology gets to them, the technology that I'm about to tell you. Okay, so the Paris Accord emission targets, I have them listed here somehow. The United States, we just left, and they don't care about this anymore, but they said they would reduce emissions by 2025, so last year, about 25% lower than the baseline from 2005. The European Union, they said they would reduce emissions by 40% below the 1990 targets by 2030. By the way, they're not going to be able to do it. They're not able to do it. What they will do in a few years when they say they cannot do that, I don't know. It's a mystery, but they're not going to be able to do it. And by the way, this is one of the reasons why carbon credits are so expensive in Europe. It's a way to encourage companies to start decreasing their emissions quickly. China had, by the way, these were all agreed upon targets at the Paris Accord. Okay, there was a lot of fighting, but this was agreed upon at the end of it. China said they would have peak CO2 emissions by 2030 and reduce CO2 intensity about 60% from 2005 baseline levels, also by the year 2030. And it seems to me that they are on track to getting that. I think they're on track. But I'll talk about these numbers in a minute because it's very hard to understand. I mean, we're talking about China 2005 levels, we're talking about European Union 1990 levels, we're talking about the United States 2005 levels. What does that mean? The United States was a very big emitter in 2005, and China was a very tiny emitter in 2005. This is what people refer to as historical rights. So the conversation is very, very complicated and but now it's a numbers game. And that's where you're strong. And you're going to see how this becomes an interesting numbers game. So have India, Canada, let me just move on. Okay, and now I'm about to become mathematical now. I'm going to start to develop some of the techniques which we will need to do that. When I say mathematical, I really mean AI. There are no models here. We don't have data. We don't have models. And in doing that, there is one sentence I want to share with you. I know that you already agree with me, but I want you to be explicitly aware that this famous mathematician, Paul Erdős, from Hungary, just over there, he said a mathematician is not someone who knows how to add, is someone who knows when to add. And that's a very important description because as you will see, everybody can add. We saw that everybody can use Excel and then people believe that what you get is right. So this sentence could also apply to my second lecture where we went through quantitative methods, right? It's not the number, everybody can do the number. Is that the right number? And that's basically what it says. And I want to do that, and I want to tell you about this. This is how I got started in this whole business myself. When I look at these numbers, I'm going to give you a very famous table. It's the table of contributors to greenhouse emissions. This table is very famous. And everybody talks about that, and everybody talks about China. It's the biggest emitter. And the numbers I have here is like 10 gigatons per year. So everybody's focusing there. China is producing 5 gigatons. Number 2 is the United States, which is 5 gigatons, half of that. Okay, now we already see something here. China is what, 8 times the size of the United States? The economy is lower, but the number of people is a lot bigger, right? So it's 4 times. So it's 4 times. So what's the right comparison? The economy is lower, but the number of people is. So what's relevant? Is it the emissions per dollar of GDP? Or is it the emissions per capita? Or perhaps neither of them, right? So if you do emissions per capita, which is a number that some people look at, especially people in China, they look at, say, well, look, on a per capita basis, China, even if you divide by the number of people, China disappears. Their emissions per capita are very, very low. They don't even show up, right? But then, of course, you see who shows up. The countries that show up are the countries that have very small population. There's a very interesting country there. That's Canada. Canada is number 7 on the absolute basis, and also number 7 in the relative basis. And it's not that it's the same number; it's that Canada has very high emissions for a very important reason. We're a huge country. We're the second largest country in the world, and we're empty. There are very few people, and most of our emissions come from agriculture, right? We have a lot of our agriculture is a very big emitter of, so that something tells me, and something told me that these, well, the numbers are right, the interpretation is wrong. Very similar to the example we saw on Wednesday, when we're calculating things and it didn't really explain reality properly, right? So I'll tell you something that I did. It's just to give you an idea of the kinds of things that one can do here. And what I did is let me give me the data, ignore everything else, give me the data. Let me try to find out a way in which I can understand emissions as they relate to socio-economic variables. Because every country has, they have population, they have GDP, they have surface area, they have many things, and maybe all of them contribute to emissions. So if looking at emissions only is the wrong thing, dividing emissions by a number is also the wrong thing. What's the right way? Is it linear regression between your emissions and a number of market factors? Doesn't work. See, now what are we doing? We're doing exactly the same things that we were doing on Thursday, when we're trying to understand. In that case, we were trying to understand performance linked to factors. And we had a linear factor, we had nonlinear factors. You see, it's exactly the same. So we did that. We came up with 6 factors that matter. I did that with 2 of my graduate students. And we found what are the factors that matter. And these are nonlinear. We did that with a well-known technique in machine learning, support vector regression, that you know, okay? And we got it. Okay, I don't have any hope that at the next climate agreement, when the countries are fighting again to see what their targets are, that they're going to consult me to see what my model says the numbers should be. That's not my intent either. Okay, I did this because I wanted to understand these numbers from a mathematical perspective, and I got it. But there's some very interesting application of that, which is how I think about that. So, well, then that will allow me as a person, to create my own baseline calculation for every country emission numbers. Because I know how to relate emissions to socioeconomic variables in a way that it works for all countries around the world. It's an exercise in data management. That's what it is. Data science, that's all. Now you give me a country, which could be in my database or not. Invent your own country. Just give me the parameters and I will tell you what the emissions should be, right? You can do that because I'm doing a regression model. Very similar to some of the regression models that we saw on Thursday. The nonlinear ones, the ones you see in machine learning. So then what I can do is give me the countries. Now I compare my target numbers with their actual emission numbers. And there's a difference. And the difference is what you have in these graphs. I'm not interested in going through each of the countries and tell you this is Italy, this is, I don't care. The interesting thing is I can do very interesting benchmarking for emissions using AI. Well, machine learning. Using machine learning. And then I can see countries that are becoming browner, their emissions are increasing, or countries where emissions are decreasing, they go down. And this is just by looking at data, nothing else, and not a lot of data. Okay, so I started like this. This is the first paper I did years ago. So then I said, okay, so this is interesting, because now I need to reflect on how innovation happens. We're talking about things which are new. And there's something I want to share with you. You probably agree, because you're young. Older people disagree with me, but younger people agree. And I like to think of the 20th century as the century where innovation was given by a very small data. Perhaps the biggest accomplishment of the 20th century was to send the man to the moon, perhaps. Okay, I know that we just did something similar, but I think 20th century the biggest accomplishment was probably that. Okay, and it was the man, not the women. They were not there. Okay, they were there this time, but not there. Okay, but that was a system. That was an accomplishment that we did with very little data, lots of equations, and it was in physical space. That was the 20th century. The 21st century is completely different, in my opinion. It is going to be something where we have a lot of data, not one equation, and everything happens in mental space. And everything I'm telling you about what my science fiction is exactly like that. Okay, you may agree or disagree. I think you would agree. I think you would agree. Older people disagree. No, they love their models and their equations and this and that. I said, that's finished. I don't believe in that. But all of this is powered by one very important element. Now that's why you mentioned that, data, right? Data is what's powering this transformation. And now I need to say, well, if I'm talking about science fiction, where is the data in everything I'm telling you? And the data is, numerical data, like in the area of finance, you know that very well, is Bloomberg. But now we have textual data, and we already saw how important that is, for example, to understand GameStop. Okay, or how important it would be to understand ESG flows. But there's other things. We have now a plethora of sensor-driven data which is being produced. I have some of the companies here who are big producers of that. And even data that comes from satellite images, and for example, this company, Planet AI, is one of the suppliers of that. This is where things are beginning to be very different. The big data providers are no longer going to be the Bloombergs of this world. There's going to be new companies that will be providing the data that we need. Bosch is a big producer of data, but a lot of the data comes from their own devices, from their own infrastructure. The Planet is a little bit different, but this is beginning. Big voids here. The data needs we have for this is going to be a topic of its own. And I want to just share some of that with you. I remind you this picture that we saw a few days ago. It was my reflection of the last 100 years of quantitative methods that started with pencil and paper, then went to computers, then went to PCs, the democratization of computers, and now we're dealing with AI, where everything is different, right? So we're in that, and we cannot think like that. So for you, trying to understand your business opportunities, your employment opportunities in the future, you think like that, okay? Whatever remnants of this are there, take the job for a limited time, but that's not going to last, okay? And something I like to say that social trends are the new momentum trades. We talked about that already in, I forget when, it was, I think yesterday, no? Okay. And I have to tell you, this is a product, one of my students, former students, did this. They have it's a beautiful system. They have a product that they sell, and the product is you name a company, and it will do for you in real time a better than ESG classification of the company over time. So pick your categories, not just E, S, and G, just pick your, and then it does that for you using large language models, for example. The big competitor is not a competitor. this is better than what the ESG companies do. The ESG companies is Refinitiv, is MSCI, is S&P themselves, right? These are big behemoth pieces of information which no one knows how they're done. Everybody knows they're wrong. Everybody knows they don't agree with each other. So this is something that is one of my students is doing. Is fantastic. But this is now part of I want to adopt a different perspective on this, and this is a risk management perspective, which is how I think we're going to understand what we're up against when it comes to the business development of these things. And I want to talk about this question. I want to use this analogy because I want to explain a lot of what we're talking about. I said sustainability is the new liability. So there's a clear insurance component in the way we think about everything. So I want to adopt the insurance perspective now. And I do that by presenting you with this risk thinking framework. There's a law everywhere in the whole world that if an airport is hit with thunder and lightning, then you have to close the airport. You have to stop, no flights. Okay, it may have happened to you. Yes. Okay. Yes. I fly very often to New York. In New York, they always have this. Like every time I go, there's a storm. But imagine that airplanes were allowed to fly. And imagine you go to board your plane, and the plane, there's a big thunderstorm there, active lightning, and the plane is going to go, and you have to decide if you go on the plane or not. And you cannot change flights. They won't. There's no refund for your ticket. It's either you lose your ticket or you board the plane. That's the only chance you have. What do you do? So don't answer. I'm going to do a little bit of thinking about that. There's arguments in favor and against. I'm just trying to develop a way of thinking about risk, which I haven't brought to you yet. So you can say, you can be a physicist. I say probability says that you're likely to have a problem because physics, as Faraday's law, that says that if the lightning goes, hits the plane, it's going to go around it, and there's no problem. You're going to be safe. So why would I lose the price of my ticket? I just board my plane. But there's another way of thinking, which is if you're wrong, you die. So how do you think about that? I want to use that to develop a new way of thinking, which is, I call it risk thinking, which is what do you do when you don't know what's going to happen? And this is very important because in the 20th century, we've been miseducated that we always know the outcome of what we do. We always know the outcome of what's going to happen. We've been trained in a system where the outcome is known. The 21st century is not going to be like that. Everything will be stochastic. The deterministic part of this world is already understood and we're done with it. Everything is, in particular, climate change is deterministic. I told you about 20% of the scenarios are very bad, 80% are not so bad. It's the 20% that worries us. It's like boarding a plane. Yes? So to do that, I'm going to play this game with you. You may have played this game before, but I still want to play it with you because it goes to the bottom of the root of the difficulties in implementing this thing. So we're going to play two games. In the first game, you have a choice. You choose A, I give you $900. If you choose B, you gamble. 90% chance you make $1,000. 0% chance you make nothing. I can do a very quick vote, but I know the answer. Who chooses A? Who chooses B? Usually 10% of the people choose B. Maybe someone on Zoom should choose B, okay? But now I change the game, and if you choose A, you pay me $900, and choice B, you gamble. Okay? So who chooses A? Okay. Who chooses B? You all gamble. You all gamble. Why do you do that? Why do you do that? You've seen this game. Yes. Why?
Same reason we do the first time, like we're not sure to pay, so we have a small possibility to not pay.
It's very hard to come up with a mathematical model that will replicate this. Very hard. This is how the human brain works. This could become now a course in psychology. The human brain is a risk management machine, a very good one, by the way. That's why we're alive. And a lot of our chemistry, if I talk about hormones and neurotransmitters, actually is enhancing that risk management aspect of us, the humans, where we've been designed at birth to survive. And we don't like risk. In fact, they said another version of this, which is people have done the analysis. 92% of the fears you have, of all the things that you think would be bad for you, that you worry about, 92% will never happen. And this is getting worse now because, I mean, it looks like we have less things to worry about, so we make up things to worry about. And that's why there's so many cases of anxiety and mental health problems and this and that. This is all understood, okay? So again, I know I'm touching psychology a little bit, but no, I want to bring this back down to what we did, and I want to go back to the first example we started with in my course, the snow fund, the snow swap in particular, okay? Let me read the snow swap from this perspective because it's the same thing. I could say that both games I placed earlier are pretty consistent with what we discussed with the city of Montreal and the ski resort. The ski resort could decide not to gamble and just well, if I'm going to just enter into the swap, I pay some money, but then I'm protected. I say, no, I'm going to gamble. It's very unlikely I will not get snow, and if I don't get snow, I'll tough it out. I'll just do it. But if I get it, most likely nothing will happen to me. So the ski resort is confronted with exactly the same game that we dealt with earlier. And the city of Montreal had the same thing. They could also decide to not gamble, enter into the swap, or gamble and say, well, look, if I get a lot of snow, I'll pay. Big deal. Right? It's the same game. Cities and ski resort companies typically act in a more rational way than people. I don't know why. Maybe because they have committees, maybe because or maybe because at the end of the day, if something bad happens to the companies, you know what? I'm still alive. Companies have limited liability. I don't care. Companies have been designed to protect them from risk, and you only have upside. Maybe that's why companies act differently from people. People die, but we have no upside. Our upside will stay alive. Companies have no downside. Bankruptcy, big deal. Upside, I'll become a trillionaire, right? Maybe, I don't know. I don't want to get into that. But the interesting thing is that the reason why you have different points of view is the reason brokers exist. Because what a broker does is a broker will actually shift the game from here to there. In fact, I could arbitrage yourselves because you chose game A in the first case and game B in the second one, right? So I take the other side. I changed my numbers a little bit, and then I would make money from you all the time. And that's why brokers exist. And that's why market makers exist. They charge you a little bit, and then they allow you to change the game that you think you should have, but you don't want to. Okay, that's how the brokers exist. Okay, so when you're dealing with a situation where you don't know what's going to happen, you always need to do the same thing, which is you need to look at your known knowns, your known unknowns, and your unknown unknowns. Someone here asked me about Nassim Taleb. I don't know who he was, the first day of classes. I was surprised. This is actually the language of Nassim Taleb. So I'm dealing with that now. Yes. And this applies to everything. He uses a turkey at Thanksgiving. I mean, you're not Americans, this analogy may not work for you. But he says, well, a turkey knows that it has a good life, has food, home, and he doesn't know how long that will last, but he does not know that Thanksgiving is coming. So that's his end. So he does that to demystify the value of historical data when you do risk management. I'm not going to use it in that context. But I want to say that this works all the time. It worked for Silicon Valley Bank when they said rates are low. I am very happy with my bond investments, very safe. He doesn't know when rates are going to go up, doesn't know if the leverage is adequate, doesn't know if the deposit will decrease, but then the Fed raises rates by 5% in a few months, they're out of business. Happens there, and it happens in the snow fund. We thought we were happy with our portfolio, and then Intrawest came in and destroyed our investment. It's always the same. It's always the same way to organize your information. It's this support. So when it comes to climate risk in 2026, I should say now, continue a little later, okay? These are the known knowns for climate. We know, as we explained, that reflected sun rays, will warm up the atmosphere. And there's the known unknowns that this could have an effect on sea levels going up, and who knows where other things. Okay, and things could get pretty bad. We know from computer simulations, things could get pretty bad. We could even have the Gulf Stream reverse its course. That would be dramatic. That would be horrible. And there's a chance it might happen. Okay. And then there's the unknown unknowns we don't really know. So the way I would think about risk when I take my flight is very similar, which is I miss my flight, that will cost me something, or I gamble. The problem is that when I gamble, if I'm wrong, I die. Right? So I'm going to go there. Okay. So the insurance premium perspective to think about these things is as follows. There's a delicate balance between three numbers. One is the mitigation cost, also known as the option premium or insurance premium. You pay that, you're fine. The other is the loss probability and how much the severity, the loss value in case something goes bad. Right? And the relationship between this is what drives decision making. I'm telling you how the insurance company works. Now, it is just to be clear, a common mistake is to think that the insurance premium or the mitigation cost or the option premium is the probability of loss times the loss amount. It's a very common mistake. That's only true if your risk is hedgeable, if you have a replicating portfolio. But if not, that's not the case. You have to add a piece of the uncertainty to your calculation. Okay, so if I give a probability space with events and this and that, the insurance premium is not the expectation of the losses. That's not true. You know that. If risks are hedgeable, it could be true. If risks are diversifiable, it could be true if you sell a lot of them or if you have a very big portfolio. But in general, even in that case, it's not true. This typically underestimates the cost. The mitigation cost should be a lot higher. Okay. Why am I telling you this? I'm telling you this because when it comes to climate change, everybody's making their own calculation. First of all, people like to gamble. And the reason they like to gamble is because they miscalculate the mitigation cost. The mitigation cost should be a lot higher than people think. That's why. So the calculate. I mean, but I think you know this. You've taken courses in insurance. I have here a very. I'm going to go quickly through this because I think this you already know. But this is how these things are priced. If I have a situation where the expected value of an auto policy claim is $1,000 and the probability of an accident is 10%, then one claim would be $10,000 from that. Then what happens if I sell a single policy? Just one policy. If I sell one policy, what should the price be? Well, if I say one policy, only one policy, my risk function is a Bernoulli distribution with a $1,000 expectation at $300 standard deviation. You can do that yourselves. It's very simple, very, very simple. What happens if I charge the mean $1,000? Well, I'll go out of business with a probability of 10%. What happens if I charge, say, 10% in addition to the mean? I'll go out of business with a very similar probability. Bad idea. What happens if I go into a fully diversified portfolio? I sell 1 million insurance policies. So if my risks are diversifiable, what is it? That becomes a Bernoulli. That becomes a normal distribution. I call it it's a Bernoulli with many, but it's really normal. $1 billion mean and a $300,000 standard deviation. In that case, if I charge the mean, I have a 50% chance of going bankrupt. But if I charge 10% above the mean, that works. I have a very small probability of going out of business. And that's how insurance companies work. And that's the insurance premium calculation. So this leads us to be able to price risk in the right way. And again, I think you know this. The typical way to price risk is to take you charge the expected loss always, but then you charge a percentage of the standard deviation of that. Okay? Okay. So let me take this into a business case that I want to do very quickly for you. It's the Nyaliga fire project that happened in northwest Australia, in East Kimberley country. What they did there is a very interesting project. This was a regulated carbon trade with the Australian government. It's called the Emission Reduction Fund. What they did is this. Savanna fires are very, very bad. They happen naturally. Okay, the savanna just burns. Forests burn on their own, randomly. And when that happens in the dry season, it's very bad. They burn at scale for a long time, and of course, a lot of emissions. So what the Australian government did is funded a company through carbon credits, so that this company, run by Aboriginal people from there, Kimberley country, East Kimberley, what they do is they do controlled savanna burning during the wet season. So you get rid of the dead wood during the wet season by burning it. You have a picture of the person there burning it. Okay. And then when the dry season comes, there are hardly any fires. And after the fact, they have discovered that the area burned is 33% lower. It's great for grass and wildlife. But what they get paid for is a 40% reduction in emissions. Okay, now this is a great business case. Great business case, you actually get paid to burn the savanna. And you get paid because you've reduced the emissions. It's true. But ask yourselves, how do I know? This is all I get. I don't care for that. I don't get paid for that. I get paid for this. How do I know that the emission reduction is 40%? How do I know? I'll show you. Watch. There's hundreds of pages of disclosure statements, audit reports done by consulting companies like KPMG. Look at things like that. Humans with boots go there, they take measurements, they fill reports, This takes months. And that's how these things are accounted for. You see that? Okay. How would you do it faster? Any one of you can do it faster. How can you do it faster? Give me an empty audit report. Put it into my large language model. Tell me what parameters I need. That, okay, great. I have my army of drones. I just need a few, 3 or 4. Connected to my computer, which I program so when the drones go over there, they take measurements and the computer extracts all the variables I need and I give it back to the LLM and say, now you fill the report. So you can do this in as long as it takes for you to fly the drones over the territory. You understand that? Understand that? That's how these things will be done. This thing takes months. And there's a lot of money involved in that, a lot of money. Right? So this is what I used to tell you. This is the accounting job of the future that you want. Or not. Or maybe you want remember how we created a fund? There was the administrator, the accounting firm. Who was my administrator? I can replicate my fund with this example. I forgot who was my administrator. Okay. Was you?
I was, yeah.
Maybe you were? Okay. So yeah, I think it was you, yes. Okay, so you're the administrator. You're the one who has to verify that these are the right numbers. So you get your drone army and say, done, here you go. Now you pay me, right? And you do it fast. But now once I have that, I have my chief investment officer, I forgot who that was. So well, now that I have that, I know the amount of money I can get for that, and I know that it will cost me only to do this. It's a big investment, I do that. Right? And then I have my lawyer. No, I could do that because and by the way, we can get the money for that according to this market that you just told me in Europe or in China or somewhere. And everything that we created on day one can be recreated every time you have an opportunity like that. And this is not science fiction, by the way. There's science fiction in my course, not this. This is happening now. But it's happening very slowly in a way which is very, very inefficient. I have a video here, which is in my website. I want to go through that. Let me tell you something. I'll become personal. I'll tell you things that I'm actually doing myself. This is how we're doing what I just told you to do. We have a company in Spain. We're doing this. We take satellite images or drone images, even better, and we calculate all of the components of the biomass, living and dead, which are the basis for your carbon credits calculation. And this is done through actually my master's thesis student, Franziska Stigling from Munich. She actually worked on that. So this gives me my way to calculate my CO2. We're already doing that. We're already the accounting company doing that. So what I'm telling you is actually true. And it works in a very nice way because with that, I'm showing you the app that we have. Okay, I'll be done with this in a minute. So you give me a location, you give me a certain type of tree. Oops. You give me a location, a certain type of tree, and I can get you the output. All AI driven. And so this is not something that it's probably science fiction. I hope this will grow, but the whole world is going to have to do things like this. I am already doing some of it, but this going to, and this is where the great opportunities, I think, will be. So we can replicate the entire financial system that you already know with securities which are very strange, with money which is real, but coming from different sources, and with volumes which are predicted to be huge. How huge, I don't know. But I already started my lecture today talking about the value of the electricity we get from the sun. I don't know how to measure the water. The water is there. But let me move into health. How can I measure health? Because the new health that's coming is going to be preventive. It's not going to be reactive. And it's not going to be physical or chemical. It's going to be digital. And it will be done the same way. So everything you're learning, I can almost guarantee, will be used in a completely different way. And if you have any doubt, do some research how the derivatives market was in the years 1960, because that's where we are. Okay? We take a break. We come back, and then I'll give you the end of all of this. So I'm done with the business aspects of all of this. I'm now going to go into last half hour. What do we need to develop that? Everything we have learned in this course can be used for this, because after all, it's all different types of investment methodologies. But this is more difficult than anything we have done. More difficult than anything we have done. And one of the reasons is the financial market, the financial sector is fairly easy. The data that you have is the prices of this, the yields of that, and we've learned how to put it together. But now we're dealing with very complicated things. We want to understand how the earth works, right? We want to eliminate poverty. We want to eliminate hunger. We want clean water. That's much more complicated. So there's one thing we have not done, which I'm going to develop now. And someone asked me yesterday, it was you maybe, someone asked me yesterday about this. I said, well, I'm talking about this now, which is causality. I want to talk about causality. And I want to start by doing this in the following way. Okay. I like to, I want to start by telling you the difference between causality and association. Everything we have seen here is, so far, it's been association. Even when we did our machine learning techniques, we work with association. Association logic is something happens at the same time as that. Whereas causality is something happens because of something else. So for example, if you acted from association logic and you're sick, very sick, you do not go to the hospital because that's where people die. So association logic will tell you to stay at home because if you go to the hospital, your probability of dying is higher. So that is what we're aiming at. We're going to come up with a framework so that we can analyze those things from that perspective. And I do that by this author I like very much, Steve Koonin, who wrote a book. I like him very much because I disagree with everything he says. He gives me wonderful counterexamples to mention in class as to how what he says is wrong. He's a great scientist, by the way, great physicist, provost at Caltech. I was at Caltech for 3 years of my life. But when it comes to causal logic, it's wonderful. So he wrote a book and settled, and he has two very interesting arguments in favor of CO2. He says that CO2 levels contribute to a greener world. He does say, something which is true, that CO2 is plant food. So he said, well, where are we worrying about CO2? The more CO2 we have, the better it is for plants, because plants will grow greener. We'll have more food, it's all great, it's good for everybody. And he's right. I'm going to do a lot of causal graphs now in the last half hour. It's all about causal graphs. So that would be the causal implication. CO2 implies plant growth. Yes? Of course, we agree with that. But the thing is that this is not the whole causal graph. There's a piece of the graph which is missing. CO2 contributes to the warm-up of the Earth stochastically. Okay, stochastically, we think it's very reasonable. And this is the problem, because this thing is going to lead into storms, into floods, into maybe increased coastline. That's just a wink to Donald Trump. And that is what's going to cause loss of life and loss of money. And that's why we do it. We have nothing against plant food. You need to be fully aware of the causal graph. You need to understand what you're doing, which includes the loss of unintended consequences. This is one of them. You can say, well, I want to increase the levels of CO2 so plants grow greener. Yes, But then you have the unintended consequence, which are also part of your causal graph. And I guess you understand what a causal graph is. Great, okay. Now, but the most important argument of Steve Koonin is this one. He says, look, in the 20th century, we have seen the highest increase in emissions, and at the same time, the highest reduction in world hunger. So let's continue to emit more CO2, and then world hunger will continue to go down. He writes this in the book. Yes, he does. Okay, so let me write the causal graph. That's my way to look at these things. I'll write the causal graph, and if the causal graph says that I'm right, great, I'll accept it. So the causal graph is I have CO2 and I have hunger, and I know these two things are negatively correlated. I accept that. The more CO2, the less hunger. But again, what's the causal graph? The causal graph is the reason we have the causality for lack of hunger is that we have more food being produced, and we have global supply chains, which contribute to food being shipped from here to there. And all of that came because of engineering and agromechanics that were developed in the 20th century, which allow us to create more food, and by the way, to also give us better transportation systems, which is what is causing all of the CO2 emissions. So that's the causal graph. You would probably agree with me on that. So whether CO2 and hunger are correlated or not, it's irrelevant. It's the causal graph that is telling us what should be, and if CO2 and hunger are correlated, that does not mean that if you increase CO2, hunger will go down. That's not true. You have to go to some of the other elements there. So there's a name for this. This is what is a causal graph, and these things are called the confounders. A confounder is a factor that oftentimes you don't know what it is that gives rise to that seemed relationship. So if I go back to my example of I'm sick, I go to the hospital, and that's where I die, and you may think there's a positive relationship between that. The thing is no, there's a confounder, which is how sick you are. Very sick people go to the hospital. People who are not sick do not go. That's the confounder. And that's the one that really explains that seemed association, which is really a causality to a different confounder. So what we're going to do now is I'm going to show you how we can redo everything we have done in this course. Everything will have to be redone, like nothing works. Every time we used correlation, wrong, we cannot use it. We have to find the causal graph and act according to the causal graph. So we're no longer allowed to do a single correlation analysis anymore. That's very tough, because from day one I used correlations. That's how I went from one swap to 100 swaps, remember? So if correlation is removed from what I'm doing, then I'm defenseless. Well, no. Let's go into causality. Let's understand how that works. So causality is all based on A implies B. And I'll give you some examples of features, outcomes, and interpretation. I'll go very quickly here because I think you all know that, okay? In finance, if I have order flow imbalance, that creates a short-term return. And this is what we very well know, that buying pressure predicts price move. So that's causality. I could talk about trade intensity and the impact on volatility. I could talk about bid-ask spreads and the impact on volatility. All these things are well-known causal relationships, and you know them, and they are accepted. Because we know the causality, now you are permitted to go into correlations. Correlations should only be used when we know the causality is there. Okay? So now you have to revisit everything you know. From you're starting to learn, you go back to year one of your studies, and every time you see correlations, say, question, was causality there? Because if causality was there, you're right. If causality is not there, that chapter is wrong. You have to rewrite it. Now, I'm not going to rewrite everything you know in 20 minutes. That's not my intention. But I want to show you how this is done and what the consequences are. Because when you deal with complex systems, correlation is not useful. It's not good enough. That's my last message in this course. It looks like I'm ending my course going against everything that I lectured about here. And that's not true. It's just that I told you it was a very important assumption that I hid under the rug, and now it's coming up at the last minute. I said, okay, everything we did was true because of that. But if that's not the case, then this is how we do it. So I have more examples here. I have examples for equity factors. I guess you know that. I'm just going to go through this quickly. Momentum. I think, in fact, some of these things we already discussed. Let me spend a minute on credit, because on credit, this is actually, I got this from ChatGPT just to be sure. ChatGPT told me that credit spread implies higher default probability, and therefore that would translate into the market pricing of risk. That's not true. You understand? That is not true. It's one of the, I don't know if you saw this in your credit, but that is not true. It is not true that the higher credit spread translates into higher default probability. No, this is a confounder. What's the confounder? What's the cause that's leading to both of them? It could be the leverage of the company, it could be the debt ratio, it could be it's something financial in the company that creates at the same time an increase in the credit spread and an increase in the default probability. It is not true that there's causality here. Okay? I have another one. Leverage implies higher leverage, higher equity volatility. That's true. That is because it is not the other way around. You know that, oh, your equity is now more volatile, your leverage is higher. No, my leverage is what it is. I didn't change my leverage because my stock went up, right? That causality is right, but the first one is wrong. The first one is wrong. Or CDS spreads implies equity drawdown risk. Yes.
But suppose it's that way and assume that something implies the other.
Yeah.
How would you know that's the case, assuming you don't have any data?
Oh, no. So all of this, okay, I should have said, all of this, I assume I have data. Yeah. No, in fact, without data, there's nothing I can do. Without data, maybe, in fact, that's not true. Without data, I can get you the causal relationship because the expert tell me. But it's useless for us. There's nothing we can do. For this course, I need the causal relationship and the data. Without the data, there's nothing I can do. So sorry, I'm assuming I have databases for everything. Okay? Yeah. So in the case of credit risk, I'm very proud to tell you that we actually, this is a paper that we wrote. This is the causality for credit risk. 100 different factors, and we know what implies what, with what weights and everything, and it's in one of my papers. So I like this. This is what I do. And we understand that. Okay, but let me continue. Because when it comes to emissions, let me look at the causality of emissions. And I know that a high carbon intensity implies higher cost of capital. In fact, that's probably what you're doing in your courses, I assume, right? And the reason is that investors price transition risk. So if you're a high carbon intensive company, then investors know you are going to be expensive to rebuild or to and so that includes a cost of capital, and that's why you have to pay more for that. And people who do economics, like you told me you're doing, you would be. So this is a well-known high. I didn't talk about the scope 1, 2, and 3 emissions. Scope 1 is when you're a direct emitter. Let me just say that. But if you have high scope emissions, then you have higher regulatory risk. Of course, because the governments are being regulated. That means they have direct exposure to policy. And there's a few others. So in emissions, we have that. There's different factors that imply factors. And that's another area where I've been very active. And this is the causal graph that we developed with my collaborators. And we have that. Okay? I don't expect you to, just to show you that these things are doable. This is not science fiction. This can be done. Yes?
But the fact itself that people might believe that high carbon intensity generates a higher cost of capital, doesn't it generate like causality from ignorance of people? Like if you have a model, for example, or banks that are trading on this belief that it's not true, but they do trade on this belief, then couldn't this create some kind of causality?
Okay. So what you're saying, the way I would, let me not answer, let me just rephrase your question. What you're saying is that there's the high carbon intensity, there's the higher cost of capital, and there's people ignorance. Well, let me treat that as a factor. That's where I would do, right? And that's why you see in my, I don't have 2 factors here. I have maybe 70 factors here. That's how you do it, right? And then you get it right. Then you always get it right. And to his question, when you do that, make sure you have a database of people's stupidity. You need a stupidity index per person. Real or a proxy, but you need it. Okay? Yeah. Always. You're right. You need data. And with data, this becomes extremely powerful. Let me tell you that. Extremely powerful. What I would now have to do is I will have to review all of finance, everything, so that it works like that. Good luck. Most of the things that you have studied are correct. But a few would be incorrect, like the one on credit I just showed you earlier. So I doubt that for most of you, this is an issue while you're students. Just graduate, get your degree. The real game starts after that. And after that, just be aware that everything you have studied should be from this perspective. And when you deal with very complex issues, like emissions, water management, world hunger, you have to be taking these things into account. There's one thing, it's not, I don't have a slide about this, but it's one of the things that I do also. There's a very common misunderstanding, I'll show you. It's, people have calculated that if every country spends 0.7% of their GDP on aid to countries in Africa, then African hunger will disappear. Have you heard that? Yeah, it's there. Someone did a calculation. That's not true, not by itself. Because the problem you have is you can feed the people you have now, but then these people will probably have a lot more people because they live longer, right? And the growth rate, the population growth rate in Africa will explode, and you have an infinite population in finite time. So you need to control that. So you need to be aware of all those factors, right? It's very important that when you're doing something, you have the whole graph, not just a piece of the graph. Because with a piece of the graph, you get to the wrong conclusions. Okay? All right. So all of this is based on the concept of the confounder. And I guess you know that, but I'll still go through that just in case. It is oftentimes thought that causality means that the probability of B conditional on A is bigger than the probability of B. You've seen conditional expectations. So is that causality? Some people think that's causality. It's not causality. I'll give you an example. The probability that it rains when I have an umbrella is higher than the probability of rain without looking at whether I have an umbrella or not. That's true. Except for me. It always rains when I don't have an umbrella. Okay? But for most of the people, it's like that. If you get me a database of days of rain and people having umbrellas, they say, oh my God, umbrellas cause rain. Right? No, right. Of course not. Of course not. That's not true. What happens is that there's a high correlation between those two numbers, but it doesn't mean that one causes the other. In fact, to do that, you have to do something, which is what I need to tell you now, is you need to do interventions. That's the right way of doing experiments. Intervention. What's an intervention? Intervention is the following. Let me stay with the example of umbrellas and rain. If you want to understand if umbrellas cause rain, what you should do, what we should do is the following. They say, I'm going to do an experiment as follows. It's called intervention. I'm going to do a data set, which is I'm going to get a bunch of people to always have an umbrella. And then I measure that. And then I measure the rest of the population with or without umbrellas. I don't care because I only look at the probability of rain. So look at two data sets. This is an intervention. It's called also a randomized trial. And then when I do that, what do I get? I get the probability is the same. Right? The number of days of rain is independent whether I look at my population with umbrellas or population maybe with umbrellas, maybe without umbrellas. And that's how I conclude that there is no causal relationship. Umbrellas do not cause rain. That's how you do it. And as you can imagine, this is very important for health. But it's also very important for emissions. It's also very important for many people think that, for example, emissions, oh, I forgot to tell you. Many people think that lower emissions implies we're all going to be poorer. Says who? I had a causal graph for emissions. It's not true. You can actually lower emissions and become richer. You could do that. The causal graph will tell you that. Okay? And by the way, that's how you will construct interesting businesses and interesting investment opportunities, by realizing that the causal graph allows you to do things that maybe defies logic and certainly defies correlation thinking. That's the other thing. Correlation is a very constrained measure of dependence. And it may make you think that some things are just not possible. Well, that's because you are looking at the wrong or too small section of the whole causal graph. Make it bigger. Make it bigger, and then you'll have a better understanding. Okay? So that's what I'm doing, promoting causality. And in doing that, there's a very important concept. It's the concept of the do operator. The do operator is what I'm doing this in the case of rain and umbrellas. The do operator is I want to create a data set where I force umbrellas to always be there. That's the do operator. Okay? And the way you write that it's not conditional. It's a different type of conditional probability. It's not conditional. Okay? Probability of rain when I force umbrellas to be there. And you have to conduct a randomized trial of that. In finance, you cannot do that. In finance, it's very hard to do that because that will force that you have to create a data set. And finance, you cannot create a data set. They're all given to us in real time. And if you're sleeping, they continue to be produced. You cannot stop. So this only applies to situations where you can conduct randomized trials. You can say, okay, now everybody have an umbrella and go out. In finance, you cannot do that. So in finance, perhaps everything you've learned is as far as it can go because you cannot have the do operator very often. But you can do it in certain situations. A portfolio with or without that. You can implement the do operator and some characteristics of your portfolio and then run your analysis and determine causality that way. Okay. And so that it's written like that. The probability of rain, conditional that I force intervention that I get people to wear umbrellas. Okay, and that will show me that I'll get a table like that. The probability of rain, I get a certain number, and the probability of rain conditional on the do operator on umbrella is not changed. It's the same. So there's no causality. Eliminated. And that's how you build causal graphs. Okay, let me. I have here how you would do a randomized trial for a drug. This is what people do for drug creation all the time. If I do the probability of recovery of a person conditional that they take a certain drug and say, oh, it's bigger than if they don't. Well, if the data set is given to me without a randomized trial, if the data set is given to me where I didn't force patients to take the drug no matter what, or force patients to not take the drug no matter what, I don't know that there's a relationship because there's a possible confounder, which is sicker patients are more likely to take the drug. I need to break that relationship, or I need to make that confounder relationship explicit. So what I do is I calculate the recovery probability conditional of no drug, and then I see what numbers I get. You understand what I'm saying? And then, for example, I have an example. Imagine that I do the probability of recovery taking the drug is 70%, probability of recovery not taking the drug is 50%. So I do two sets of randomized trials where I force the drug and I don't force the drug. And that determines that there may be another confounder, but the relationship is clear. And this is always done like that. The concept here is a directed acyclic graph. When you do causality, you need to have a graph. A implies B for all possible A's and all possible B's. And this graph is directed, meaning that one thing implies the other, or the other way around, but you need to know what implies what. There must be a causality structure between the nodes. That's the directed part of the graph. Then it's acyclic. Acyclic means it contains no internal cycles. I can say A implies B and B implies A. Not allowed. Or A implies B, which implies C, and then C implies A. Not allowed. You cannot have a cycle. This is not very constraining if you're not going to build cycles, you're not going to build graphs today, but maybe tomorrow. If you have a situation like that, what happens is the nodes that you think are nodes are not nodes, they are clusters of nodes. Okay, so what you need to do is you need to break them up. Because if A implies B and B implies A, you said no, then there's some things within A which are individual events, and A is just a cluster. You need to break down A into individual events. And then you will see, and you do that until the cycles disappear. Because if some things in A sub 1 implies B sub 1, which implies A sub 2, which implies B sub 2. Oh, that's okay then. I don't have a cycle anymore. I broke down A and B into their cluster components, and then I get a cyclic graph. Okay, so the graphs have to be acyclic and directed. And with that, and I finish now, you can do wonderful things, because when you do that, then correlations are welcome. And the correlations are typically done in the form of causal betas, which are done like that. You can do that. And by the way, you can do that with betas. You can do that with betas with an activation function. You can even do a neural network if you want to. That's okay. It can be built like that. And yes, you need the data for that. But with the data, now once you get the causality, you know you get the right betas, okay? And this is good because this empowers us. This now helps us do the right thing and not just do calculations. And I can tell you that the way I do that is I do this as a two-step process. The first process is I get the causal graph. This is something which I do without data, just the causality. A implies B. And I do this. This is expert knowledge. I don't need the last piece of information about this. I just need to know that I need that when it's warm, people have ice cream. And I also know that when it's warm, people go swimming in the ocean. So if now I see that there's a relationship between people having ice cream and people drowning in the ocean, I know that if I outlaw ice cream sales, I don't save people from drowning, because there's a confounder, which is it's warm, right? So I use my knowledge and we use LLMs for that, to construct my causal graph, where the only thing I know is the direction. I just know if the beta is positive or negative. That's all I know. Sorry, beta, no, I know the direction. Sorry, the beta could be negative. I know the direction. Okay? Once I have the direction, then I bring in my database, and then I do the causality. Then I do the causality. And I can calculate my causal beta, and then I know what implies what. And I have here an example of the type of prompt that we use, so you can see that the prompt is actually pretty substantial. It's a prompt like that we get to understand how the causality is built. Okay? And to this date, I think the most complicated thing we have done is the causality for emissions, which is here. So emissions is here. Okay. and then GDP is somewhere there, and the urban living is somewhere there, and that's how you understand. And now you can say, I want to decrease that and increase that and make sure that I don't have to, sell half my country to my neighbor. So that's how I will decrease emissions. All right? Okay, so that's what I wanted to share with you. That's my science fiction. I am pretty sure this is your future. You will be involved in some of these things. I could be right, I could be wrong. In any case, you learn causal AI, how to do causal AI, which is very useful. Okay, and on that, I still have 5 minutes if there's any question.